My name's Chris Murphy. I'm an Unreal Engine Evangelist. Someone's at the door. So I work originally as a tech artist, but also a bit of a generalist as well. My role in projects has always been kind of a bit of a difficult one to define. For tonight though, we're going to be covering a couple of topics that I really wanted to start kind of approaching some cool stuff you can do within Unreal, some just kind of the fun stuff, but also just opening up your minds a bit to things that are achievable. I find that one of the most important things in game dev, for me anyway, has always been most things are reasonably straightforward. They're small patterns that when you reproduce en masse, you can create something really cool, right? But the interesting thing for me has always just been, it takes someone to show me that a pattern exists the first time, and once I know that it exists, I will rip it apart and do whatever I can, and it'll be cool. But there's always that period of time where I quite often need to see a concept. So, as I was saying before this all started, one of the things that I do quite commonly is whenever I see something in a game that I think is pretty cool, I tear it apart and I try and reproduce it myself. Even if it's not in Unreal, like if it's in COD or if it's in whatever else, I'll sit there and I'll be like, all right, how could I do the same kind of thing? What's it going to take for me to do it? And that always helps me understand things because I'll figure out a design pattern that I can then just reapply and reapply and reapply to 1,001 different projects. You know what I mean? So for tonight, we're going to be creating something kind of interesting. I'm just going to create a blank project called BrisTech project because I'm that inventive. And then we'll just give it a second to load up and we'll go from there. Now, if at any stage, this project's going to be kind of free form. I'm going to be doing my best to just, oh wow, everything is on wheels. Okay. I move the desk. All right. I'm going to be doing my best to kind of work through with everyone. I am going to pull out my phone though and be a little bit rude, just so I have a point of reference for a couple of the things. It's the kind of stuff that I both know, but know that I can screw up reasonably quickly. And if I mess it up, it'll take me a little bit of debugging, so I'd rather just have examples there. So please forgive me for that. Yeah. So what I'm going to be doing to start off with is I'm going to pull in some of the assets from the marketplace. I'm just going to rip over the Infinity Blade Grasslands stuff. So I'm just add the project. This is called BrisTech project. I'm just going to quickly just add those assets in for me because it will be way more interesting if I have something that isn't a table. I mentioned last night that typically whenever I start a new project, the thing that I'm destroying is those tables over and over and over again. We're going to do our best to avoid doing that tonight. And instead, we're going to work on something else. I'm thinking a rock would be good. So just going to quickly grab an asset that we have in here. This plains rock, I swear it's rock mesa from UDK. I also think that it's really dangerous to be able to recognize rocks, but that's okay. So I'm going to get this, and I'm just going to drag this into the scene so you can see what we're kind of messing with for the most part. Just going to delete the starting stuff. Okay. There is our rock in all of its glory. So we're going to work through a few things. Initially, what I'm going to do is I'm going to create a material that creates this as if it was some sort of hologram. So it's going to go and just assemble it. That's the sound effect it's going to make in my head the entire time. So just make sure you're all ready to add the ambience when necessary. I'm going to start with that. I'm going to move on to something a little bit cooler as we go forward. So for this, what I'm going to do is I'm going to begin by going to my content browser. I'm going to make a new folder, and it's just going to be called Effects. Okay. Now, this is just going to be where I'm going to throw everything for the time being. It's not going to be a particularly organized project this evening. I'm not caring about where things are ending up. I just kind of care about showing you the results of what it is that I'm trying to achieve. And I'm just going to call this M_vertical creation. Yeah, that sounds cool. Let's do that. Okay. So vertical creation is what we're going to be using as our material. Just going to drop you on you. And I'm going to open this up, and I'm quickly just going to get the existing rock stuff that we have, which was this rock. I'm going to set this as my default mesh. So I'm going to click here, and you can now see that the rock is cooking. We've got that, and I'm also going to apply the default textures that it used, which I suspected these two. We'll find out really quickly if this normal map and such don't match. I'll have to look it up, but reasonably sure it's those two. That looks promising so far. I'd say we got a winner. Cool, so we've just got our basic rock and everything looks how it usually would. All right, so we've got our rock, and from here what I'm going to do is I'm going to start looking at this idea of moving around aspects using the world position offset. Can I get a show of hands here of who's ever touched world position offset in Unreal? 3 of you? Who's intentionally touched world position offset? Okay. You've got someone out there again. So, sorry, the glass window is facing me, so I'm the one that's kind of like spotting them. So we've got ourselves a situation where we're going to use world position offset. Now, there are 2 ways that you can move vertices around in the shader. You can use it through either tessellation, or you can do it through world displacement. Sorry, world displacement or world position offset. World displacement does it when it's a tessellated mesh. World position offset just gets an existing vertice. Now, I know I may have just jumped through a lot of stuff just then, but essentially what I'm talking about is, if I want, I can move any vertice in Unreal around by simply accessing like where it is and just pushing it up, down, left, or right. And that's what the world position offset output does over here. So an example of that would be, just really quickly, if I was to go ahead and get the world position offset, if I was to get a sine wave, sine, I'm just going to get sine. And what I'm going to do is, if I were to get time, so the current time in the game, and run it into a sine wave, we're now going to get it doing between 1 and -1 and 1 and -1, right? Because that's what a sine wave does. So if I was to get something like that, and then plug that into the world position offset, what we're going to see is very small, so I'm going to multiply it by a big number. You've got someone at the door again, Alex. Now, I'm just going to multiply that by a bigger number. I'm going to multiply that by 50, just as a quick thing, and I'll show you what's going on. So can everyone see that? Now, what is our rock doing when I plug that in? Anyone? Gyrating. Gyrating, yep. So here's what it's actually doing. It's moving between, every vertice that is in the model is moving between -50 on the X, Y, and Z axes at the same time, and then up to +50 X, Y, and Z axes at the same time, which is why it's doing a diagonal movement, because it's actually shifting simultaneously on every axis. If I was to get that and multiply it only against the Z axes, which is the up and down axes, so I was to multiply it against 0, 0, and 50, just as an example, it's now going to move up and down on the spot. Can everyone see that? Now, here's where things start to get interesting. If I wanted to, I could actually also do some other stuff. So I could access the vertex normal, which gets me the direction that the vertex is facing, and I could multiply that by, say, 20, and plug this in. Anyone see what it's doing? Every surface is compressing in on itself and then blowing itself out again. Compressing in on itself and blowing itself out again. P.S. If you ever need to make a heart mesh, this is a good way to do it. And you know, this is obviously going to break at some stage if I crank up the number too high. But we can start to get a feel for what's happening, right? So in this situation, every vertex is getting a different thing. They're not moving uniformly. Every vertex looks at the way that that is currently facing and then shifts in accordingly. Does that make sense? Wonderful. So what I'm going to do here is something way cooler than this. And that is, I'm going to go ahead and I'm going to access a position on the mesh that is going to be, I'm going to create the equivalent of a plane, okay? So a flat square that is sitting beneath the mesh. And what I'm going to do is, Alex, the door, I'm going to move that plane up and down, and use it as a way of shifting vertices within the mesh, okay? Now, what I mean by that is I'm going to do this. If I was to go ahead and get the actor's position in world space, okay? So that gives me the location of the actor. That doesn't give me the location of the vertices. It gives me the location of the actor. Does everyone understand the difference between those two things? Every vertice has its own unique position, but the actor has a single central position, okay? Now, by getting the position of the actor, I can then also go ahead and just make a value that's just going to be called Z offset, okay? And I'm just going to create this and set it by default to say -200, okay? And all I'm going to do here is I'm going to get the actor's position and subtract 200 from the z-axis to find a overall point in space. So I'm going to go ahead and get a what's called a component mask. So at the moment, the actor position outputs x, y, and z position, right? But if I was to go ahead and access this and mask it, I can tell it to only export the B channel. Now, what's the B channel? Anyone? So the B channel is the height. The B channel is the z-axis, so it's up and down, okay? Now, if I get these and I add them together, I now am able to find a position, like this value here is going to be 200 units beneath where my actor's z location is, all right? Now, the reason that I'm doing that is, check this. If I now go ahead and get the world position of the current vertice, and I look at the distance between it and, I want to get the distance on the z-axis between it and the actor's z-axis. And just a quick thing here is that I'm going to output the distance, but this isn't going to look very good. The reason it's not going to look very good is if I preview it, we're going to get that. Anyone know why I'm getting that? If I make it positive 200, you can see what's going on. Distance is giving me the distance away in centimeters, okay? Now keep in mind that a value of 1 when output as a color is full white, which means anything that is more than 1 centimeter away is now going to be super bright. Does that make sense to everyone? So if I divide this by a distance, and I just say divide it by, say, 200, it now means that when I preview this, we can now see that we have this, any pixel that is equal to that offset here is going to be black. Any pixel that is further away is going to be white. And if I wanted to, I could clamp it to make sure it never got too bright as well. So why is that useful? Well, that's useful because if I wanted to, I could start to use this to control my world position offset and do some interesting stuff. Because, so right now I have the distance between, the current vertice and this imaginary plane in space, right? Now, because I have the distance between the two of them, what I can do is I can say if the absolute position is below the, if the absolute position is currently below the offset position, I can do a world offset that is equal to the distance multiplied by just on the z-axis. It would be this versus just this. I think I did that right. Nope, backwards. Definitely backwards. Okay, can anyone see what's happening here? Watch this. If I get my z offset really quickly, and I'm just going to set up a sine wave that's going to change the z offset over time so we can see it moving. So to do that, I'm just going to add a sine remapped, which just gets a value with a sine phase. So I'm just going to run time into that. And I'm just going to make it a value between 0 and my offset. And I'm going to plug this into here. Can anyone see what's happening here? So if that was actually between, say, negative, if this was between 1,000, I guess. Anyone see what it does when it reaches the top? It actually flattens every vertice to that plane unless the pixel is above it. Does that make sense to people? So I'm probably doing this backwards because whenever we wanted to create something from the ground, we would probably want to create it from the ground upwards. So to do that, all I need to do is just flip my A and B. And then set this to be, I think, -1. Yeah, that'll work. So now I'm just going to make sure that my positions are set and tell it to go between, say, -200. There you go. So if I was to apply this and drop it in the world, so it's a little bit clearer for you to see, what we have is this. Now that's pretty quick right now. So I'm just going to get time, and I'm going to divide time by a value of like 5, 6. That was accidental. And now so can everyone understand what's going on here? We're grabbing the position and we're moving it, because we know the distance between it and the plane, we can just say if you're currently like above the axes, we want to, if you're below the axes, we want to, no, above, I was right the first time. We want to pull you down to the plane, but if you're below the axes, just keep you where you should be. That way, as the verts reach their actual position, they'll stay in place. You know, if we wanted to, we could add some extra stuff as well, so that as we approach the bottom, we pull the verts in. That way, we kind of get this, and it forms down out of a thing, which would look like the trap in Ghostbusters, I guess. It's really cool, but I'm not going to get sucked in by myself. Okay, that's the start of something cool, but let's make this a little more interesting. Let's go ahead and remember before we could calculate the distance between it. So you can see here that I can see this line moving up and down the mesh. Yep. Actually, I'm just going to quickly swap these two values because they're technically backwards. Like a sine wave doesn't matter, but it's just where it starts is a bit different. So what I'm going to do here is, at the moment, I'm getting the sine wave just remapping between these two heights, and it's giving me this, and that's great. But because I have the distance here, if I wanted to, I could divide this by a number, say 50, 20. 20 sounds nicer. Start previewing it, and what I end up with is this. Yep. Now, if I was to get this value that is currently being divided by 20, I was to clamp it. So does everyone know what a clamp does? A clamp, if it's between any two numbers, all it does is, if it's between 0 and 1, any number that would be higher than 1 is now equal to 1. Any number below 0 is now equal to 0. Does that make sense to everyone? So by clamping it, you see that we go from blooming to just being a flat color here. Yep. So I can do that. I can then go ahead and I can, if I do a 1 minus, it's going to flip my black and white on a clamped value, because it's going to, like 1 minus 0 is now going to be white, whereas 1 minus 1, which is white, is now going to be black. So we end up with this. Why is that cool? I'll show you. It's cool because if I hit M and I drop in a multiply, and we get some cool stuff happening, I can then just drop in like some sort of vector, emissive color, plug you in. I'm going to set you up as, someone pick a color.
Red.
You ever say aubergine?
Yep.
Dead to me. Okay, let's go red-ish. I'm going to go, okay, cool. So I'm going to plug in those values. I'm going to stop previewing. And we're going to look at this in the game. Can you see what's happening now? So because we are able to isolate that band, like in space, we can then multiply things against it and do some pretty cool effects. Right? Now, if I wanted to make this slightly cooler, I could do other things as well. So I could go ahead and, what's a nice thing to do? Okay, yeah. By the way, remember how I said I planned these things? I lied. No, I planned it out, but every time I'm doing these live demos, I start thinking of cool things that I had no intention of doing. If I wanted to get a noise texture, so I'm just going to get some Perlin noise. So Perlin noise by default looks like this. I'm going to get that texture that's currently wrapped around the rock. I'm just really quickly going to throw a panner onto it so that we can just get a little bit of movement. It's going to just look like that. Actually, I want it to be a little bit slower than that. Whoa, whoa, missed the decimal. Yeah, whatever. Getting too picky, but that'll do. If I wanted to, I could get a value like this and just quickly multiply this against a value, say 5, 10. And I could subtract that from my mask. Now remember, by default, my mask looks like this. But if I were to subtract this gradient, this noise from it, it would now look like this. That was way cooler than I expected it to look. But that's all right. I'm just going to hit stop. And now when I look at it in the game, how much more video gamey does that feel? Yeah, I'm just going to sit here and just marvel at it for just a minute. Just pretty proud of myself. Nah. So you can see how I'm going, like with these kind of effects are kind of cool, right? Like we just made something, like it didn't take me too long to get that up and running. And here's the thing, if I'm spawning items in a game, do you know how much cooler it looks when you're playing a game and instead of just it scales up from 0, which is what a lot of people do, it just pops into existence by going boop, like you would in your, like it's just that age-old thing. How much cooler would it look if, like, when something is forming, like a demon is starting to give chase? Because you could apply this, if you wanted to a character mesh. So whenever you play like a summoning animation for a spawn effect, your player could actually just be like, nah, and just materialize from the ground up, and it would look sick. So keep it in mind. What I'm going to do next, though, is I'm going to make something a little more interesting, which is going to require some blueprint integration, as well as a couple of different meshes that are all sharing a little bit of information with one another. And this is the section of the project I am most likely to mess up, FYI. Okay? So what I'm going to do here is initially, I want to create something. I'm just going to save my minimal default map. I'm going to go File, New, and I'm going to create an empty level. Okay? Completely empty. Why? Why would you do that? I would do it because if I was to get rid of this and create a new material, I'm just going to call this m_starfield. Also, I really like real-time demos because when that chills out there and it does that, it just feels really cool. If I was to have a starfield, I'm just going to generate a starfield that's going to be in the map. So I just need one thing here, really. I need to get a sphere of some descript that I'm just going to drop into the world. I'm going to multiply it by a very big number on every axis. Okay, that may have been too big. We'll figure it out. I'm just going to then also set its material to be the thing that I just created, which is going to be starfield. So I'm just going to set it to starfield. And now I'm just going to plug in noise. Sorry, I want a... if I plug you into emissive, that's what we see by default. Actually, I probably wanted a regular noise now that I think about it. So if I plug you in, that's what a regular noise looks like. Can everyone see that? I'm just going to set this material to be two-sided. That way it renders on both the inside and outside of the sphere. Now the reason I'm doing this, just really quickly, is if I go into the world, that's what we've got. What I'm going to do is if I get a noise and I multiply it against a slightly different noise, it's only going to show white where both values are currently white. So I'm just going to set this to like 0.5, 0.1 maybe. And if I then multiply that against another noise, oh yeah, okay, why not two of them? It's going to really quickly just generate some sort of star field. Okay, apply. Starting to get somewhere. Still way too much though. So all I'm going to do here is I'm going to power it. So show of hands of who knows what a power node does. Power just gets a number and makes it something like whatever the exponent is to the power of the value that's going in. The reason we use this is it's a very simple way for us to add contrast, because 1 to the power of 2 is still equal to 1, whereas 0.5 to the power of 2 is going to equal 0.25. So it's going to push values towards dark unless they're close to white. So the closer it is to a black color, the quicker it'll get dark. And I'm just going to punch this up to like 20. That shouldn't have done that. Okay, I know why. It's because this noise value is currently needing to be clamped. So I've just quickly pushed that up to there. There we go. We've got something that's a bit more of a start field going on. That is totally just not coming out on your screen. If I drop this down a bit, it should work a little bit better. Sorry, I didn't realize how strong the contrast was on this screen. Okay, that's excessive. So, but you can see how I've just quickly generated some noise. Now the reason I've done this, and you can do this in a lot of different ways, but I'm just going to find a value that I like. I'm going to hit apply, I'm going to hit save. The reason I've done this is because what I'm actually going to do is I'm just going to, because I didn't have a star field texture already laying around, actually that's pretty good. Because I didn't have a star texture laying around, I'm just going to get a scene capture cube. Just going to get it and just drop it at 0, 0, 0. Now all this camera does right here is that it takes a screenshot of the current environment that it's in and saves it out to a texture. So I can create a cube render target in my effects folder that's just going to be called rt underscore starcap. And if I open this texture, RT Star Capture, you can see here that it actually is saving out the environment around me into a cube map, okay? So I'm just going to get this, and there's a nice little cheat thing that I can do whereby I right click on this and I hit create static texture, and it just saves out a version of that right now, and instead of real-time capturing it, it just leaves it. Now, so I did all of that purely for the sake just then of having a star capture, but that's all right. The reason I did that is that if I open up the original map that we were working on, I can now start creating some cooler stuff. Okay, Rock, you're dead to me. You've had your time. So what I'm going to do is I'm going to go ahead and make two things. I'm going to have a portal in space that's like floating there, and then I'm going to have a big asteroid. And how the asteroid's going to work is, you've got someone at the door. How it works is that as the asteroid, you look through the portal, you're going to see the asteroid approaching. But if you're not looking through the portal, we're not going to see the asteroid. Does that make sense? And then as it breaches the portal, it'll look all completely rad and just like shoot out of the end of it. Okay? Yeah. Rad. Correct. Correct. So, how do I do that? Well, I need two things. What are the two things that I obviously need to have within my build? Anyone? Portal. A portal and asteroid. Sweet. So we're going to use that rock that we had a second ago as our mesh. So I'm going to create a new blueprint that's just going to be called BP portal effect. That'll do. Okay, so we've got the portal effect, and the first thing that I'm going to do is I'm going to add a basic shape, which is just going to be a plane mesh. Now, one little thing I want to point out right now is forwards for my plane is which direction at the moment? Yeah, it's pointing upwards. So I'm actually going to be getting the up vector a couple of times, where if this was set up correctly, I would be getting a forward vector, which would be along the x-axis. Just be aware that I'm going to be accessing it that way. So I've got this, which I'm just going to rename to portal. And I'm going to go ahead and make another static mesh component, which is going to be called Asteroid. I'm going to parent the asteroid to the scene root instead of the portal. And I'm going to set this to be the rock. Does anyone remember which rock it was? Nope. Really? You're going to be like that? I think that's the right rock. Looks good to me. Yeah, so that's going to be my asteroid over here. And as it passes through the portal, it's going to look cool. For the time being, I'm just going to quickly move you over to here, rotate you around. I'm going to just shrink down my asteroid as well. Something that's a little bit more manageable. And I'm going to beef up my portal size to be about 6. It could have gone too far on one of them. I don't know which, but it's happened now. Okay, yeah, you'll do. So I'm going to get my portal, and I'm also just going to quickly get it up that way, so it's facing along there. So this is what I have at the moment. It'll look better in a sec. So it's time for us to start making. There are two sides to this that we could choose to make. I could make the asteroid first, or I could make the portal first, either or. I think it's probably going to be cooler for me to make the asteroid first. So it's at about this time that I'm going to make sure that I've got a point of reference going so that I don't mess all of this up at all. Wonderful. Just got my point of reference. Now, what I'm going to need is, okay, so how do I make an asteroid invisible if you're looking at it through the portal versus not? Actually, do you want me to show you the effect that I'm creating first so you can get a better idea of what it is that I'm making? The final effect is going to look like, I hope GIFs play when you double click them. Ask me later. Final effect we're creating is going to look like that. Okay? Now, you'll notice that the asteroid is not visible on this side of the portal, and then it comes out. Okay? Also, sometimes I just really love my job because this is rad. Okay, so let's make a big asteroid. So I need to make it so that I can't see it from one direction and I can from the other. So the first thing that I'm going to go ahead and do is I'm going to create a new material that's going to be called m_asteroid. Okay? Now m_asteroid, I'm just going to quickly just copy pasta the two textures out of here because I know they're correct. Content browser, m_asteroid, so I'm just going to drop them in. That's going to be my base color and my null. And I'm going to also plug in the mesh itself, which is called rock2. And I'm just going to tell it to be that. So this is what we have by default, okay? Simple rock. Okay, so we've got this kind of placed, and that's what we're going to work with. The thing that we need to calculate for all of this is going to be based off of my mask. So I'm going to mask out the areas of the rock that I want to see and the areas of the rock that I don't want to see. Does that make sense to everyone? Cool. So what I'm going to do here is I'm going to go ahead and get a vector that I'm going to add into my material. And this is going to be a variable that we change and we set to, if I want to make a portal, I need to know three things. All right? I need to know where the portal is in space. I need to know which direction the portal is facing. And I need to know which direction it's facing, and I need to know how big the portal itself is. Does that make sense to everyone? Right. So this first one is going to be portal location. Okay? Now this next one is going to be portal forward vector. Okay? So that's going to be the direction that it's facing. This is going to be where it is. Okay? Now the thing that we're going to work with here is, if I was to get the world position of every vertice that we currently have, what I'm going to get is, I'm just going to clamp this so you can see it a bit better. We start previewing it. Now, if I draw the current world position of every pixel onto this asset, this is what we see. Now, who here in the audience can describe what we're actually looking at here? Anyone? Why are we getting some weird colors? X, Y, and Z. So X corresponds to red, Y corresponds to green, and Z corresponds to blue. Does that make sense? So what happens is, as the pixels go along the x-axis from 0, they're going to become red. As they move away from the x-axis, they're going to become black. Does that make sense? Now, essentially what we need to do is we need to, instead of finding out the pixel location in terms of the space of the, by the way, did you order pizzas already? He's good? Sweet. Oh man, lost train of thought. Yeah, instead of finding out where the pixel is in terms of world space, we need to find out where the current location of the existing pixel is relative to the portal opening. Okay? So we need to find out if the portal's facing this way, we actually want to project them along that axis instead. So that's the first thing that we know we need to do. And the other thing that we need to do is create a cylindrical intersection between the two locations. So to start with on that, I'm going to go ahead and I'm going to create, the best place for me to start on that is going to be the cylindrical intersection. So I'm going to right click and type in cylinder. And luckily enough, there's actually already a sweet function called cylinder intersection that I can start taking advantage of. If I open this up, I can see what it does. It's kind of complicated. But essentially, this projects a cylinder into space. Essentially, it's projecting a cylinder into space with a position, a rotation, and then it's telling me whether I can see the cylinder or not. Okay? So what I'm going to be doing here is I'm going to set it up with a few things. Its origin, just going to move this across. Can you read all of that okay, by the way? I'm trying to zoom in where possible. Make sure, again, if I lose you at any stage, feel free to raise your hand and I'll try and explain what's going on. If I get this and I plug in the origin, I'm just going to tell it for the time being that its position is 0, 0, 0. I'm going to tell it that the forward vector is going to be the direction that we're currently looking at the cylinder from. So I'm going to plug that into the z-axis. Now, this forward vector is currently set to 0, 0, 0, so I'm actually going to give that a default direction, just something that is visible to me. Okay. I'm also going to go over here and just this mask, I'm going to go ahead and make a component mask of the B channel, and I'm going to preview that. Okay, so you can actually see what's going on there. So everyone see this cylinder in space? The rock is bigger than the cylinder, so it's always going to be able to see a cylinder if I was to look through it. But if I was to change the radius on this to say a larger cylinder, the moment that's set to 0, I'm going to crank it up to 320. Okay, can you vaguely see what's happening there? It's picturing a cylinder on top of it. And wherever we would be able to see the cylinder, like the rock through the cylinder, it does that. And wherever we can't, we're going to get blackness. Okay? Now, if you think about what our portal is going to require, it's going to require me to have a capped cylinder, which I think it is by default. And it's also going to require the size of the cylinder to be, can anyone think of what size the cylinder actually needs to be? Basically, it actually needs to be a 0 point in space. So that. Can everyone see that now? Now, what I'm essentially going to be doing is I'm going to now have to work out which direction I'm looking at the cylinder from to work out whether I can see things through it or not. Okay? So what I mean by that is I'm going to go ahead and get this, and this part I'm probably going to lose you a little bit, unfortunately. I'm trying to think of how the nicest way for me to explain this is really going to be. Yeah, let's just see what happens. Okay, I'm going to go ahead and get a function that's called transform to z vector. Now, z vector takes in a center location and a direction, and it then converts something from one set of axes, like world position, into another set of axes, which in this situation is what I'm going to use to figure out which direction I'm looking from and whether I can see this or not. That'll make a bit more sense in just a second. But I'm going to set this up so that essentially the z vector that's getting read in is going to be the portal forward vector. And hopefully if I do a component mask on this and just get the B channel, you'll be able to see what's going on. Can everyone see that? Remember I put in 0.333, 0.333, 0.333? That essentially made kind of like a diagonal angle. If you imagine that I got... who here doesn't know how direction vectors work? It's totally fine if you don't. Okay, that's fine. So you know how existing vectors work, right? Whereby it's a point in space. A direction vector is essentially, imagine that we were at 0, 0, 0, and whatever number was getting read in, we were pointing towards. So if I read in a number of 0, 0, 1, we would be pointing directly upwards because we would be pointing at a pixel in space located at 0, 0, 1. If, on the other hand, my value is 0.3, 0.3, 0.3, my value is going to be a little bit along this axis, a little bit along this axis, and a little bit along this axis, which creates a diagonal direction. Does that make sense to people? Great. So by getting this, I can now figure out which side of the portal I'm looking, like the asteroid is currently on. So if I was to get this initially, I'm just going to get this, and I'm going to straight up just plug that B value into the opacity mask, so you can see what just that is doing by itself. I'm going to set this to be masked. Where's my blueprint? So at the moment, this is going to be, oh, I haven't actually applied the material. So at the moment, it's kind of trimming off because I'm hard coding that value. Can everyone see that? So it's at this point that I'm just very quickly going to set up in the construction script. I'm going to get the asteroid. I'm going to create a dynamic material instance of it. The source material is going to be m_asteroid. I'm going to promote that to a variable just so I've just stored it, and it's just going to be called asteroid mid. Mid stands for material instance dynamic. At which point I'm going to create a new function that is going to be new function. It's just going to, oh, I've got pizzas, great. Yeah, throw them over there, and I'll just quickly get this part done. It's just going to be called update asteroid. And all we're going to do whenever we call update asteroid is I'm going to get the asteroid material instance dynamic, and I'm going to set a vector parameter on it. And the vector parameters that we're going to set are, can anyone remember which values that we created? We had the portal forward vector, which is going to be equal to the up vector of the, because remember the plane was facing downwards. So I'm going to just get that and feed that in as the portal forward vector. And I think the other one was called, was it portal location? Is that what I called the variable? Probably. I'll just try it and see if it works. So I'm also going to set the, I'm going to get location, and I'm going to plug that in as the value here. And I'm just going to call this, I think it was portal location. That was not quiet. Portal location forward vector. Cool. Great. And in theory, if I compile, save, oh, whoops, and I've got to tell this to do it as well to the mid. Great. Compile, save. So I've just set that up like that. And in my construction script, I'm now just going to tell it to update asteroid. So can everyone see that? So the Z is currently doing this. However, what I want to do is when I'm this way, I still want to be able to see the asteroid through the portal. And when I'm this way, I don't want to actually see the asteroid because I want it to kind of be occluded by the cylinder itself. That way we don't get these weird back faces because they're ugly. So to set that up, what I'm now going to do is I'm going to get the, when I am getting this channel, I'm going to, on one side, I'm going to get the max between, I'm going to get the max value between that and the Z vector, which is this. So if I hit start preview. So one side of my graph is going to do this. And the reason for that is, I'm just going to clamp that in just a little bit. And now on the other side of my graph, I'm just going to get this one little bit done and then we'll be good. I'm going to go get the min between the two values. So min between this and, oh sorry, between this and 1 minus. So it inverts it. And I know that sounds weird, but that means that on one side I see this, and on one side it's going to be that. And to blend the two of them together, I now need to do one last thing. I swear, sorry guys, we're almost there, and then we can eat the pizza. Next, I need to convert the camera into plane coordinates to work out which side of the asteroid I'm on, which, again, I know it's kind of a strange one, but I convert the camera into... I get the same transform vector location that we had. Oh, by the way, sorry, actually, I forgot to set one little thing, which is the center location. That has to, oh, sorry. This has to be plugged into, because we hadn't moved it yet, we're not seeing it, but that had to be plugged into there. And the vector to transform by default is absolute world. There we go, cool. The last thing I'm going to quickly do is just get the coordinates of the camera in the space of the portal to work out which side of the portal I'm on. And then this will be done for the most part. This is actually the most complicated bit, so you have my apologies if this is kind of losing you. I need to get the camera, I made a comment. I need to get the camera position in world space, and I need to transform it into the coordinates of the portal, which is going to be z vector is equal to this, center point is equal to this, and this connects to a lerp, and this is the last thing I need to do. Max, min, A, B, start preview. Oh, yeah, of course. This needs to know the B channel of this value. Okay. I may have put those two values backwards. So I've definitely put something backwards, and what we're going to do is just quickly while we eat pizza, I'm going to work out what.
Okay. Yeah, we're all good.
So you can see that it's working right now. However, I'm missing a pretty important part, which is the what do you call it? Portal itself. So let's do the portal next. That's currently what it looks like. I'm going to set this asteroid to be just a little bit smaller because it's kind of huge. So 0.5, 0.5, 0.5 sounds good. In this, I've got 320 now, so this way this will work quite nicely. To this point, then I'm actually going to drag in the blueprint that we created of the asteroid into the world, so I can kind of start seeing it. Going to put it up here. So that's what we have at the moment. You all dizzy yet? Okay, so the next thing for us to do is create a portal around here. Now, this is the easier part, but there is one little tricky part that we're going to do that hopefully you're like, ooh, because it's a nice little trick. I'm going to create a new thing that's called m_portal. And the m_portal is essentially going to be a setup for us to have like a single plane that's going to look like the portal, okay? And it's going to be translucent, okay? Now, first things first, remember we created that texture a little while ago? This one, the texture cube? I'm going to drag that into my m_portal. I'm just going to plug that into base color. And under UVs, I'm going to plug in a reflection vector. Okay? Now, can everyone see that? See what it does? It's even cool if I wrap it on a sphere, actually. It basically grabs a reflection vector and uses that as projecting the cube map that we had into the thing. So the reason we use that is that if I was to now just make sure that m_portal was the thing that we were using in our blueprint, I could have this starting to go on. So it's at this point that I realize I made my texture way too high res. That's all right. People won't notice it too much. And I can probably cheat a little bit. If I was to, yeah, the problem is that when I did my capture, I captured it as a 256 by 256, and I really should have captured it as like a 1024 or something. I might just really quickly make that adjustment because it's going to slowly drive me crazy. Sorry, empty level. Just once again, I'm just literally going to drop in a sphere. It's just a material sphere. And I'm going to plug you in as space. What did I call it? Something sphere. 10 points if you remember what I called Starfield. Yeah, that sounds like a thing I called it. Rad. Cool. I'm just going to go back to my render targets. Sorry about this, everyone. Sorry, it's called a scene capture actor. Just going to set you to be in the middle. Going to set the scene target as this one. Going to crank up that resolution. And if I look at it again, that looks a bit nicer. I'm also going to do what I did the first time, which was crank up the power on it to be a little bit nicer. What I think is a little bit nicer. Okay, save. And now I'm just going to quickly capture that. And hopefully no one will notice. Create static texture. Cool. That's the one I'm going to use instead, which looks like that, whereas the previous one looked like that. Look at how much nicer that looks. Oh my god. Okay, cool. Let's go back to the map. And let's get rid of that abomination. And set it to be text 2. That looks so much nicer. Okay, save. There we go. So now we have a star field on the other end of this. Still not particularly great, and I would do something. However, what is the issue that I currently have with what we're seeing?
Can't see the other side of the asteroid.
Can't see the other side of the asteroid. So, let's have a quick look at how to do that. So, who here has ever used a custom depth buffer? I am surprised that any hands went up. That's nice. So, here's how it works. When we render the scene, we render out all the images, right? But if I want to, I can do something that's quite cool, whereby if I go to my project settings and I go to rendering and I type in depth, there is a thing here that says custom depth stencil pass, and that's already been enabled, which is good. Because what that means I can do now is if I go to my portal and I go to my asteroid and I type in depth, it has this little checkbox here that says render custom depth. Can everyone see that? I'm going to click on that and I'm going to put it on the first stencil buffer. Now, check this out. This is how my scene looks right now, right? However, if I was to go here, lit, buffer visualization, custom depth, see what we see? Or if I go here and I go buffer visualization, where is it? Buffer visualization, stencil pass. Ooh, okay, stencil's not working for some reason.
You have to, it's enabled with stencil.
Ah, you are correct. I'm off the team. So, see we have that now, and it actually shows that it's material ID 1. Can everyone see that? So the cool thing here is it actually goes off and renders just an extra pass of the scene that includes any actor that's been tagged within a certain stencil. Okay? Which means if I was to go to my portal material, and I was to say, if I was to get the scene texture, and I was to select stencil, custom stencil, which is somewhere on this thing, and I'm just not seeing it. Third from the bottom. Thank you. So if I was to get my custom stencil and I was to just grab the R channel of that, and I was to just plug you into opacity. This is going to be inverted, actually. Yeah, I think that's inverted. And the other thing I need to do is, I think I need to put a seal on the stencil, because I think otherwise it has an ID. Come on. Hang on, I'll explain what's going on in just one sec. It's also that I've gone off all of my references right now, and I'm just winging it. See that? So I'll show you a bit better of what's going on. I'm going to click on the asteroid. See what it's doing now? So we can actually see through the asteroid. This is making itself invisible wherever something is on this custom stencil buffer. But if something's not on the depth buffer, it just shows starfield, which in doing so creates the illusion that something's there. Does that make sense? Pardon? It's good. It's good. So because we're masking out the asteroid, like the asteroid masks itself out, and the stencil buffer handles the rest, we end up with this really nice illusion where something exists that doesn't, right? Cool stuff. So the next thing for me to do is to start working out, like, let's make this a round sphere, like a round portal in space, because that would look way cooler. And then we'll do a couple of other little things. I can't remember. We said this was going to be 2 hours?
Yeah, fine. Just go into
Okay, yeah. Oh, yeah. So the seal function does this. No. The seal function does... so if I get a value, that's 0.1, it just rounds it up to the next integer. So any value just pushes up to a full number. The stencil buffer by default, if I was to plug this in without the stencil buffer, it would look like this. I'm pretty sure it puts out a value that's equal to the stencil buffer value. I could be wrong there. It might actually just output to the buffer in general. Oh, yeah, okay. It outputs to the buffer in general. My bad. So I didn't need the seal. But if I wanted to make sure that every value pushed up to the next integer, rounds it off, that's how I'd do it. Looks like I don't need it, though, because that works.
What's happening at the edges of the, it's like tiny...
Getting that? So that's because right now I haven't actually synced up our cylinder to be the same as the thing. Because remember the asteroid is masking itself. The portal's not actually masking the asteroid. We're just creating the illusion that the portal is masking the asteroid. Does that make sense? Mm-hmm. Yeah, it's a bit...
Just because the asteroid's at an angle.
Yeah. So once we shrink that down a little bit and we give it like a sick electric looking effect around the outside, no one's going to know. Just hide all of the ugliness and we'll be good. So I'm going to go ahead and I'm just going to set my, first off on the asteroid, I'm going to turn down this value, convert that to a parameter actually. That's just going to be called portal size, and I'm going to set it to 300 by default instead of 320. Okay. Also, I have the chain stuck in my head, and this entire thing has basically had an entire musical going on in the background that no one else can hear. Okay, so that's set up. That's set to 300, so you can now see it's doing it a bit earlier. See that? So, okay, good. With that in mind, let's go ahead and make the portal effect way cooler than what we've done already, because it's hideous. Okay, cool. So that's all it took for us to be able to see through an object and have that illusion, right? But next up, the trick is going to be for me to go ahead and I'm going to create... There we go. Just have radial, and it'll give me a radial gradient exponential, which, if I preview, looks like that. Betting you can all see where this is going. So if I was to get my opacity and multiply this against this, that's what we're left with. So I'm going to hit apply. So you can just see the stars kind of going through it right now. But what I need to do is make this a really strong circle instead. So I'm actually just going to up the density here, which I'm just going to set to like 20, which should create just a hole in space. Cool. So now it's time for me to start working out where this value is to kind of get it a little bit nicer. So I'm just going to go, I'm going to up the radius to 0.52. Default value is about 0.5, so I think that'll be right. Yeah, pretty close. And I think when we get a rim on this, no one will notice. So I've got that as a quick section of like the thing in space. If I was to go ahead and duplicate this, and I was to do a 1 minus, which generates this, and I was to multiply that against that, think about it this way. If we have a circle that's collapsing inwards and a circle that's collapsing outwards, and we multiply them together, which is the only part of the circle that we see? The donut part. So what I can start doing now is increasing my density to kind of carve out that so it's a bit higher. And then we get this, right? And the reason that's really nice is, actually, I'm going to decrease my density now because I think, sorry, not my density, my radius, because I think 0.5 was right. I just got, yeah, for 0.5 was good. So we've got that, quickly multiplied against it. If I was to get this value that we're now spitting out and multiply that against, like by a color, an emissive color. Someone give me a portal color. Blue. Stop preview. Now, the next thing I need to do is I need to tell it wherever it's emissive, also mask out that part of the asteroid because we don't want to see that part of the asteroid. So I think that blue was kind of cool, but I really probably needed to crank up the numbers substantially to make it cooler. Closer. Bit better. I'm also just going to really quickly, because I've started on this pathway, add a power, which is going to be used to yeah, sorry, one sec. I'm going to multiply it by a number to beef the values and then plug that into there and then clamp it. And I'll explain what I've done in just a sec. It's a bit nicer. Save. Okay, good. Yeah. The ring's nicer, but now we need to get it occluding our section here. So to do that, all I'm going to do is, in the asteroid material, because we know what's getting set like as a value, like a ring. So, sorry, what I did just then was, so this is the ring that I had. So notice that the ring kind of fades out. By multiplying that by 5, I made it brighter. And by powering it by 5, I increased the contrast, but only for the values that are still below 1. Because if I power it, anything that's above 1 is now going to get bigger, but anything below 1 is going to get smaller. And then when I clamp it off, it doesn't matter because all of those values above 1 are now equal to 1, but the others dropped off, which gives me a nice, like, cleaner, tighter ring. And then when I multiply that against the color, I get this, which means if I go back to this, and I were to add that to my existing opacity mask. Add? Yeah, that makes sense. And save it. What we get. So see that ring is now occluding it? Problem is we've still got a little bit of the tail end here because I've still got to try and get in a good number for the asteroid itself. So I'm just going to go ahead and set the portal size to be just a little bit smaller. I'm going to call it 295 even. I think I'm probably only off by about 10 or 20 centimeters. There we go. Look at that. Cool. That works reasonably well. I'll probably need to get this a little bit nicer, but it seems to be working pretty well. Keep in mind as well that I can like pull this ring in as well and get some other nicer effects that would probably occlude it a bit better. Like if I wanted to, I could have like some dancing energy kind of around the edges of the ring and just whatever I wanted to have there. I'm sure would look reasonably cool. The next thing that I'm going to do though is I'm going to add some cool looking like electric rings that are kind of coming into the circle, if you know what I mean. And there's a couple of different ways I can do that. There's a really kind of cheeky way that you can do it that I personally like. So if I get a Perlin noise, I'm going to quickly load up a reference image again for this one, just to make sure that I'm on track. Yeah. So if I was to get this texture, so everyone knows, does everyone know, raise your hands if you know how UVs work. Okay, cool. So it's just X and Y and it tells it which pixel to sample. Yep. Cool thing with that is that if I go ahead and I get time and I divide that by a number, just so that it's a bit slow moving. So like, just gonna guess like 200. If I get time divided by 200 and I append that to the distance between a standard texture coordinate and a value of 0.5, have I lost all of you? We get this. So just quickly, the distance, so a texture coordinate goes between 0 and 1, right? And 0 and 1, which means in the center of it is a point that is equal to 0.5. And if I get the distance between those two, I get a radial fall off. And if I use that as my y coordinate instead of the actual y coordinate, what I get is this. And it might be a little hard to see what's going on there, but can you see that that's pulsating? It's because it's actually sampling the texture, but doing it in a radial way that's pulling a pure single line of textures out. Which,
what's the divide look like if you isolate it?
that's just going to be the time, so it's going to be like that. Yeah, because it's a position in space. So if I do something like that, and then I was to do that thing that I've been doing all evening where I've just increased the contrast. That looks kind of cool. Only the values where it's equal to 1 are we going to actually see these rings. So see I've got that happening now. And it should give me inner rings and outer rings every now and then. It's up to me as to what kind of values I want to have. Like, actually 5 looks pretty rad. Let's go with 5. So if I was to get that and kind of back before where we have the outer ring, if I wanted to, I could simply just add the current setup that I've got to include these rings and drop that in there. And there is one other thing that I need to do here, which is if I look at this here, it's a good idea for me to multiply this against the rings. Did anyone see what the issue with my rings is right now? What are my rings doing on that square that I don't want them to do? Pardon? Yeah, they're clipping the edges. So if I multiply them against the sphere that we've already got, it's going to do this to them. Do you see that? And if I then add that to my setup, I get that effect. If I hit stop preview and I look at it just generally now, we're going to start getting that effect, which is kind of cool. I'm going to need to change my contrast value again because it's a bit too hiding the coolness of what I've done. Yep. So I'm just quickly going to get that. I only want this to be like a very light thing. So I'm going to, I reckon there. Yeah. I don't know. This is one of those things that I could tweak the numbers for hours and still not be satisfied. Apply, save. What we end up with is this. Looks a bit cooler. And now the next thing that I want to do is an effect. The next thing I want to do is when we look at it from behind, we see this, which is both cool and not cool. So what I'm actually going to do is I'm going to get my portal, and I'm just going to say two-sided. Apply, save. And now you get this effect, which I actually think is pretty rad, because now it looks like I'm looking through the other side of space, and because it's gone through the portal, it no longer exists in that dimension, and now it looks like it's in ours. Does that make sense? I kind of like that. I think that's cool. Woo! So next thing for me to do is I'm going to start setting this up so that as we clip through the portal, we get like a really cool, remember that effect that we did on the first asset that we created, whereby we had that rad looking like distortion effect going on? Let's just do that because it'll be cool. So I'm going to go to my, actually, wait, which thing do you think I need to modify here to get the cool looking distortion on it? Yep. So I'm going to go to my asteroid. And all I'm going to do here is, so this B value over here, if I preview it, it looks like that right now, right? Now remember, this B value is the portal's direction, and it's facing along the way that the portal is facing. Does that make sense to everyone? Now the reason that's really useful is because we know the direction that the portal is facing. Remember before, all I did was I divided it by a value to kind of like isolate it. If I get this and just really quickly divide it by like 20 or 50, and I did abs. So does anyone know what an abs does? Absolute value. Does anyone know what an absolute value is? Nope.
It puts it in positive.
Positive, yep. Which means that -1 is now equal to 1. -2 is now equal to 2. Does that make sense? So if I had a graph that was going to do this and it hits 0, it now is going to do this. Yep. So the reason that's really useful is watch what happens when I preview the abs. See what we get? And everyone understand why we get what we're seeing right there? Great. So by getting this line, we're going to do just really quickly. I'm just going to, once again, get that line. I'm going to add, I'm just going to steal wholesale the effect that I did before because I was pretty happy with how that looked. So once again, I'm just going to get this texture sample, multiply it by a number, and subtract it from what we've got, which is, oh, I hit Control B instead of Control V. Where am I? What is going on? There we go. Just abs, and then I'm going to subtract, and then I'm going to clamp, which in doing so is now going to look like, okay, I may have gone a little aggressive. Divide by like 20 instead. So see, we've got that happening now. That's pretty rad. So let's go ahead and get that, and just going to pull this down to here for a sec. So we've got that kind of going on. And all I'm going to do here is I'm going to do a quick 1-. So I flip it. That way only this intersection is doing that. I'm going to multiply it against a value that's going to be, I'm just going to set this to be the same color as my portal so that the color scheme kind of matches. This is going to be, I'm just going to actually name this portal color. So I'm just going to multiply this against this, which is going to give me something that looks like that. And then I'm just going to plug that into my emissive color. And that's a good start. It's not the total effect of what we want just yet. So I think this needs to be super tight. You know what I mean? Like a really, really fine line, I think would look really good. So to get a really fine line, all I need to do is this number where I divided it by 10. I could divide that by something way smaller, like 2. I'm going to get something that's closer to that, which is all right, I guess. Yeah, it's kind of cool. So now if I was to get the portal, sorry, get the asteroid and move it through the portal, and we end up with that, which I think looks pretty cool. You know, we've got ourselves like a nice simple effect that it's a good start. Cool. So the next thing that I'm going to do, what do we have time for? We've got just enough time for me to okay, what would you rather see? How to set the asteroid up as basically a projectile that gets properly fired through the portal? Or particle effects so that there's like heaps of small rocks getting blown out of the thing? Wow, I'm really surprised everyone went that direction. Okay. Okay. So for the particles, that's actually easy, which is great.
We can do the other one after.
For the particles, it's actually reasonable. You know, now that I'm looking at this effect, by the way, I'm going to I'm not even going to divide this by 2. I'm going to make it an even thinner line, and I'm going to make this less aggressive. Divide you by 4, so it's let's go 2 and make you less aggressive on that front. Just because I want like a really crisp line as it kind of passes through the portal. Looks a little bit better, not great. Sorry, I'm just getting carried away now. Just 2 centimeters. It's a 4 centimeter spread. Yeah, that should work. Save 8 centimeters because it's radial. Duh. That may not be enough now.
That's awesome.
Okay, you're like, just do the thing. Sorry. Okay, so, all right, so we've got something cool. We've got the basics of that thing set up. The next thing that I'm going to do is get rocks just shooting out of the portal, because that will be cool. So to do that, it's actually reasonably straightforward. All I need to do is get my portal effects. I'm now going to go ahead and add a particle system. And now I have to quickly make myself a particle system. So I'm going to go to here. I'm going to go p underscore rubble. Okay, so that's how my particles would typically look. If you imagine each of them is going to be a rock, just use your imagination here. I'm going to get those particles. I'm going to spray them through the portal. So I want them to last potentially a little while. So I'm going to say between 1 second and 5 seconds. That looks kind of cool. So they're going to spray out like that. I want them to spray out from kind of a cylindrical, setup going on. So the start radius is going to be around, I'm going to set the radius to be 50 because that way, I think this will work. I think if I set the radius to 50, it'll scale with the size of the thing. That makes sense in my head. The initial, the cylinder location as well is going to be, going to offset it to be just down a little bit by like 100 units. That way it's coming from behind the portal. The next most important part is I need to make sure that these are, as their life goes, they start small, they scale up to a full rock, and then towards the end of their life they scale down again because we want them to disappear. So I'm just going to go size by life, and I'm going to tell you in here that, so this is a series of points that at each stage in its life, I can tell it to be something else. So I'm going to say at 0% of your life, you are 0, 0, 0. Okay, and can you see those crosses are kind of blinking in a little bit? If I look down, you'll see it. So they're kind of growing. And then I'm going to say at 0.2 of your life, you're at full size. And at 1 of your life, you're back at 0. So see how there's whoop, 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 whoop. Yep. Cool. It's at this point that I'm going to go emitter, type data, add mesh data. And we're going to set the mesh to be what's called rock2, I think it was. Now, by default, the initial size for an emitter is 25, which for those keeping track at home is 25 times the size of that rock is enormous. So I'm going to tell it to be between 0.1 and 0.15 or 125. Okay, so just quickly I'm going to drop that into the world so you can kind of see what it's doing. Can everyone see that? It's kind of cool by itself, to be honest. Next thing I want to do is I want to start them with like a random rotation because they're all currently just facing me, which looks lame. So I'm going to go to rubble, I'm going to go here, and I'm just going to add initial mesh rotation. It's just random, and here I'm going to go rotation rate. And I'm going to just shrink that down massively because I really just want like a little bit of spin on them, maybe. Lifetime I'm going to say is between 3 and 5, actually. And I'm also going to set the radius here to be 300. And I'm going to set the velocity, I'm just going to crank that up as well, to be between 500 and 200. So we've got something like that right now. Yep. So if you think about what I'm doing, all I need to do is in my initial size is, yep, good. So in my cylinder, yep, that's all set up, good. Okay, good. All I need to do here is I need to set it up such that in my blueprint, I now add component, and I'm going to add I already added my particle system, which is parented to the portal. And I'm going to set that up to have just 0 out all of its values. Cool. Oh, whoops, that was a scale. Derp. And I'm going to set this to be the effect that I just made, which is called rubble. Okay, so the problem is right now, it's scaling with the portal. So it's up to me as to how I want to handle this. If I want to parent it to that, I just need to decrease the rest of the values to go with it. 6 for 1, really. I might do that just so that theoretically, as we scaled up the portal size, it would also adjust. Which means, just going to divide you by 6. And I'm going to set the cylinder. Just spitting out like that right now. That's kind of okay. The next thing that I'm going to need to do to kind of get this effect really working is simply in my blueprint, where I spit these rocks out. I'm now going to tell it, I'm going to go compile and save just quickly. Okay, first off, in the mesh data, I'm going to click this button that says override material, which means use the emitter's material instead of the default rock material. Now the reason I'm doing that is that if I go back to my portal, when we run the construction script and we create a dynamic material instance for the asteroid, what I'm going to do is I'm going to get my rubble particle system, and I'm also going to create a dynamic material instance of that, which is going to sample the first thing's index, so the first materials index. And that's once again going to be the m_asteroid. At which point, once I've sampled that, what I'm going to do is I'm going to, again, promote to variable, and I'm just going to call this rubble mid. And if I, in update asteroid, when we call these functions here, where I'm saying, when I'm saying, oh, not that one, sorry, rubble mid. When I'm calling this thing that says set parameter value, I'm actually just once again going to re-reference this so that it's now setting that value on both of these materials at once. Does that make sense? So whenever I'm updating the forward vector on the regular asteroid, I'm also updating it on the other shader. Compile save. And the final thing here that, okay, so this is going to, in my head this will work in editor, but it should be broken normally. And I'll show you why in just a sec. So if I look, I'm just going to move the portal back. There's 2 issues with this right now. And the first people to get them, I'm not going to say win a prize because I didn't bring any with me. So something is working here, but what's not working? Anyone? Well, I mean, I didn't want them to necessarily follow the asteroid. Correct. So what do I need to do? What did we have to do before? Yes. So in my blueprint, I'm going to go to my rubble. I'm going to type in cust. And once again, I'm going to say add that to my custom depth buffer. And in doing so, you can now see them through the thing. I actually probably want to move that particle effect even further back than where it currently is. But I mean, I can do that pretty easily by just grabbing it and shifting it back to here, for instance. Because it does look way cooler when it's really coming from a distance. You know what I mean? Like when they're kind of doing... Nope, not really. I mean, I could do that in a couple of different ways. Acceleration, I could add acceleration over life and probably just fake it. I would just add at 0, you have 0, 0, 0 acceleration. At from 0.5 of your life, we start to kick in gravity, and then at the end of your life, we're adding like negative 400, I guess. So see they're starting to fall. Those were some just real ballpark figures, by the way. So, and you know, there's a couple of different ways I could do it. I could say here start to kick in, but then don't really kick in until a little bit later. So that looks kind of cool, actually. So now they're kind of spraying out. But in here, for the most part, they're not really falling until they kind of hit that portal, really. Yeah, I mean, realistically, this is actually one of those effects that would look a lot better if I had fewer of them. I know, I just said that.
Can you have them, so you like make a donut shape so they're coming out so the asteroid is actually, they're not going through the asteroid?
Yeah, there's a couple of different ways I could do that. I think in here, when I go to cylinder, I could say surface only, which only spawns them on the outside of the cylinder. Which, if I was to then scale correctly, would project just around the rim of it. You know, I could create a safe zone or something like that. Bunch of different things I could really do to kind of smash it out. And otherwise, that'll kind of work that way. But there is one other thing that's currently busted, and that is that if I hit play, see what broke? It wasn't actually the stencil buffer as much as it was just, it's not updating the material anymore. The reason it's not updating the material is there's this weird little thing that you've got to do, whereby on begin play, I need to re-reference the material. I need to call set material. It's just a weird thing with, particle systems. They're not really meant to have their materials overridden like this. So I have to actually reset it to the one that I set it up as in the construction script. And now when I hit play, it'll work. And we get this. And if I wanted to do the rest, I could fire it out. Because like the asteroid doesn't need to be a component of the portal. It's just, I just did it that way for the sake of simple testing. What I would actually normally do is make it a child actor and then just give it a projectile velocity and just pew out of the thing, which wouldn't take too long.